We're going to continue on in section 3.2 talking about synthetic division. In the first video from this section, we just talked about doing the synthetic division and being able to divide pretty easily using that. And the reason we want to be able to do that is because it does allow us to do some different things as we move forward in this chapter. And so one of the things that we can do is use what we call the remainder theorem. What it says is that if you have a polynomial, we'll call it f of x, and it's divided by x minus k, then the remainder is equal to f of k. So think about that. If you're dividing by whatever this number is, this k, your remainder is going to be the value you would get if you put k in for x in that function. For example, in the last problem that we did in the previous video, and I'll back up and kind of show you this, we were dividing this polynomial, again up here at the top, this polynomial by x plus 2. And so negative 2 was the number that we were actually dividing by. Again, it's x minus k is our form, and so x minus a negative 2. And so we took that negative 2, we divided by it, and when we got finished, our remainder was negative 10. So based on the remainder theorem, if we were to take this negative 2 and put it in place of each x and simplify, we should get negative 10. So let's look at that. So if we were to take, again, our function 5x cubed minus 6x squared minus 28x minus 2, and we divide it by x plus 2, or the negative 2 being the number we're focused on here. The remainder was negative 10. So if you substitute in negative 2 in function f, you should be able to get negative 10. So just to kind of run through the steps here, it's already printed for you. So you can see putting the negative 2 in place of x, and then simplifying that, so you're going to cube the negative 2 and then multiply by 5 and so on. You know how to follow order of operations. And then as you continue to do that, you do see that you get negative 10 when you put in negative 2 into this function. So when you evaluate this function, you get negative 10. Well, this remainder theorem allows us then to quickly run through the synthetic division, look at the remainder, and we know that's what the value is when you take, in this case, the negative 2 and put it in. And so that can be really useful as we talk about evaluating functions, which we've done a good bit at this point. If we were in a situation where we need to evaluate a function and we don't necessarily want to take the number and put it in and cube it and square it and multiply it and do all the subtraction and all that stuff, well, this is a very easy way to figure out what that number is. Simply run through the synthetic division. The remainder is what you would get. And so you can see that here. If we take the negative 2 and we do our synthetic division, which this is exactly what we did for the last problem in the last video. We went through the synthetic division, got the same numbers, and we ended up with this negative 10 as our remainder. So based on this theorem, if we take negative 2 and we put it into this function, negative 10 is what we're going to get. That remainder will always be the number you get when you evaluate the function with this number that you divided by put into the function. So let's take this idea and let's try it. So we're going to take this function, negative 3x to the fourth plus 15x cubed minus 50x plus 25, and we're going to use the remainder theorem to figure out what this would be if we put 4 in. If we were to take 4 and substitute in for x, we're going to figure out what we would get. Now, notice here we have x to the fourth, x cubed, but there is no x squared term. And then we have x, and then we have our constant. Because there's not an x squared, we're going to substitute in a 0x squared. Now, the reason we're going to do that is because in our synthetic division, that 0 is simply a placeholder. It just makes everything line up. Okay? So, when we do our synthetic division, we're using 4 to divide, because again, we want to know f of 4. If you were to write that f of 4 in that x minus a number form, it would be x minus 4. Okay, so just so you know that as a little side note. So, out to the right, we've got -3. We've got 15. Then we've got to put the 0. If you do not put the 0, it will not work out correctly. So make sure you put 0. It is simply a placeholder. Okay, so the -3 is from the x to the 4th. 15x cubed. 0x squared. Then we have -50x and then 25. We don't need the plus. So then we got 25. Okay. And so we're going to run through our synthetic division, and then whatever the remainder ends up being, that's what you would get if you put 4 in. And so, again, bring down the -3. And then we're going to multiply and add, and so on. So -3 times 4 is -12. 15 minus 12 is 3. 3 times 4 is 12. 0 plus 12 is 12. 12 times 4 is 48. -50 plus 48 is -2. -2 times 4 is -8. 25 minus 8 is going to be 17. So, based on the remainder theorem, f of 4 must be 17. Again, when we take 4 and substitute it in, we should get 17. Now, you could try that if you wanted to. If you take that 17 and I'm sorry, not 17. If you take the 4 and you put it in and raise it to the 4th power and multiply that by -3 and cube it and multiply that by 15 and multiply it by -50 and then add all that stuff together with the 25, you would find out that you do still get 17. But that's a whole lot of work when this synthetic division can be done quickly, and you should be able to knock that out, hopefully without a lot of issues. Again, if you have questions about that, let me know. Maybe something I need to explain in more detail. Be glad to do that for you. Alright, so what I want you to do is I want you to pause the video, try this one on your own, and we'll do it together in just a second. So I'll give you 3 seconds. Okay, so hopefully you stopped the video, you did this one on your own. If you do your synthetic division, again, we're using -3 because we want to know f of -3. And so notice here again, we do have a missing term. So we've got x to the 4th, don't have x cubed. So we're going to put 0x cubed. And then we have x squared, our x, and then constant. And so as we put in our coefficients, we have -1, 0, 3, -4, and -5. And so again, run through the synthetic division quickly. So bring down the -1. -1 times -3 is a +3. 0 plus 3 is 3. 3 times -3 is -9. 3 minus 9 is -6. -6 times -3 is 18. -4 plus 18 is 14. 14 times -3 is going to be -42. And then -5 minus 42 is -47. So -47 is our remainder. Again, what it tells us is that f of -3 is -47.